Hello and welcome to T1I Interventions Podcast. With your hosts, Jonily Zupancic and me, Cheri Dotterer.
And I like that you interrupted me there because sometimes their understanding of number and their understanding of visual perception are not aligned. Hello and welcome to T1I Interventions Podcast, where we share with you tips, techniques, and strategies to strengthen your core. The core classroom, that is. In the last episode of T1I Interventions, Jonily was training on number sense and how dots relate to number. At the end of what we shared last time, we're going to continue that conversation with a question that she asked me. So tune in and find out what she asked.
Cheri, I don't even know what question I have for you, but what are your thoughts on all of that? What are the struggles that kids have? What are the deficits that kids have with visual perceptual? What are many of the positive aspects of classroom teachers using visuals to gain access to the curriculum, and specifically the math curriculum? What is happening in the brain that is going to support what we're trying to teach in T1I interventions? I'm going to let you take it away a little bit and make some of these connections for us through cognitive science and neuroscience. And there's another thing you said. I'm giving you a lot right now. I know that you always talk about what the brains crave and what toddlers naturally do. Like I'm asking you like 52 questions at once, but you just take it away and give us your insight on how cognitive science matches what we're talking about content.
Well, we were having pre-discussions about what we were going to talk about today. We've had discussions about dots for a long time, you and I. We've had conversations with some of our students in the past about dots. One of the dots patterns that you utilize to represent an equation, we have some samples from kids that we have looked at in the past. But one of the things that triggered me earlier this week, we were talking about representation of dots in a different form. We were looking at it with a board. And one of the things that I was thinking about was representing dots on a pegboard. We have these different dots available. What I don't have is one of those foam boards. I just don't have any in stock at the moment. They're at school, and you know how that is. But they often have this big knobby peg that's 3 times this size. It has that knob on the end, like this one. What was it? Those big knobbies are going to be better for kids who are struggling with fine motor skills. What's nice about foam is you can pop it in and out. I was looking at different ways that we represent dots. The other way is really a bigger dot, but parquetry also creates patterns like dots. For those of you listening to the podcast, I suggest that you pop over to the YouTube channel and look at this segment so that you can see what we're talking about, because the dot representations and how the kids represented the pattern that they were copying is really impactful. These dots represented on a piece of grid paper. I don't know if you can see the dots in here, but she was trying to mimic an image that she had seen earlier that day. Jason was trying to mimic the image. It was a bit of a shot. We can see the dots a little bit better on this image. You need to know what the image was to know whether he's doing a good job at representing that the images, but he's keeping his circles inside the dots. He's doing a pretty nice job of representing the fine motor skills. This little one, Lacey, she made circles out of it. She got started, but got stuck on expanding. Lane, looks like the top part of it is formed nice. It's got nice circles, nice hand form on the pencil. Looks like he's got a pretty nice pencil grip. Then we come up with something like this that Zane did, and he knew he was trying to make an X, but had no idea how to represent the blocks and the dots. Karen, it's almost like there's a left side and a right side. They're all separate. They're not blended. She had the idea, but could not write it and represent it. This is what happens with a lot of kids with writing skills. There's a disconnect between what they see visually and what they can put on paper. One of the reasons that Jonily and I really meshed when we first met is we have in mathematics a need to understand and relate some of the disconnects there are neurologically with what they're seeing in the math classroom. Chris is working. He's got an okay pencil grip. He looks like he could be doing a little bit better with his grip. He's loose on there, but he's making circles. He started at the outside, so he knew he had to start wide and come to the middle. He may be processing it a little bit slower than some of the other kids. Then we have this one. She knew she was making an X, but that's all that she could manage. And here we have one who's, oh, this is wrong. Oh, this is wrong. And doing a lot of erasers. That's what happens with kids with memory issues. They'll do a lot of erasers, and perfectionists also want to do a lot of erasers and crossing out and redoing things.
Cheri, I'm going to say something here about Jeb, that last one that you did. In
Sure.
looking at that, just without knowing the context, you might think that Jeb has a lot of deficiencies and gaps. Jeb does have some interesting brain disconnects, but from this picture, you can't tell this, and I know who this student is. He actually conceptually is very high achieving mathematically. Cheri, this proves on this one the disconnect between what kids are seeing, what's in their brain, what they can analyze mathematically, which sometimes is a higher level than the teacher. And these kiddos were in kindergarten at the time, and he was actually teaching me things about mathematics. But then to show that on paper, it is a huge struggle for him, and pushing on the pencil very heavily. So he's got some other issues, I'm going to say. However, they're not with math content. So I wanted to point that out on this picture.
Then we have somebody like Ray, who is not, maybe the fine motor and making the dot wasn't good, but he's still doing 3x3 squares that he's coloring them in. Melissa, thought she did a fantastic job. Our friend Randy. Randy had a real difficult time with his visual perception, whether he had initiation of task, those executive functions were getting in the way, or he really had no concept, but he knew he had to do something on paper. I hope that represents and answers a little bit about where you wanted me to go, Jonily, because when I look at visual spatial, when we represent dots, are they staying within the lines and the bottom lines? Are they able to see the overlaps of the dots? Are they able to represent what they see visually? And that's one of the reasons I've liked your "what do you see" question, because if we can have them verbalize what they're seeing first before we write it down, we can more differentially analyze where the disconnect is. Is it the visual? If it's the visual, we need to start there. Is it what they're writing? Is it that motor skill? Is there some disconnect with their memory? It's breaking it down into its parts, looking at it from a visual, a motor, and a memory standpoint. We're looking at it to try and differentiate where the neurological gap is. You're looking at it and how do they represent their understanding of number? And I like that you interrupted me there, because sometimes their understanding of number and their understanding of visual perception are not aligned. And I like that you interrupted me there, because sometimes their understanding of number and their understanding of visual perception are not aligned.
That, what you just said, they're not aligned, creates, and I haven't talked about this yet, but that false negative kiddo. I'll explain what I mean by that. Earlier, I talked about the false positive kiddo that is appearing to achieve high, does well on tests, can mimic the notation, but doesn't have this deep sense of conceptual understanding. When given something out of context or a more comprehensive test like an ACT, they don't score well there. And we're confused as the adults because it doesn't match what we typically see from them in school. On the flip side of that, we get these kiddos that, what Cheri just said, the mathematics and the visual perception, they don't align. So we get a false negative reading on kids. When we're asking kids to replicate or use the visual to figure out the mathematics, many of them struggle to do that on paper. That's that misalignment that Cheri is talking about. When that misalignment happens, I can't use that paper form to truly assess what the kid's understanding is in that specific example that she had just shown. We have to be really savvy as the adults to know if this is a misalignment and not falsely target a child for math intervention that actually has a separate issue and it's not the mathematics. This is how we expose conceptual understanding in mathematics, by using these dots. And that's what I mean by assessment of watching these kids work. We had a session not too long ago where one of our participants, one of our teachers on the session said, is what you're talking about like when kids know the answer, but they don't show their work? And that's absolutely what I'm talking about here. Kids that can look at dot images or look at mathematics and they're accurate. They can actually solve, they can actually count, they can get the answer, and we demand that they show their work. This sometimes is a demand that the kiddo is just not capable of. They just physically can't. Now, that's what they need the intervention for. But what happens is oftentimes we give them this lecture. If you don't show your work, I can't give you partial credit. So I have to take all the points away. What we're doing is we're reducing the number of points they get based on something they're not even capable of doing. When we're thinking about intervention, whether it's math intervention or therapy intervention, we need to be able to analyze and work with, as classroom teachers and educators, be able to work with our direct service providers to make sure that we're assessing the correct thing. If you have a kid that's not showing their work in mathematics, it's probably because that is where they need the intervention to help them show on paper what they're getting accurately. Because again, they probably know more mathematically than we do as a teacher, but where their deficit is being able to articulate that. And those false negative kids, which means they know more mathematics than what we're giving them credit for, those are the kids that we sometimes say, oh, they just don't test well. No, they just aren't seeing the notation and symbol, and they're just not able to replicate that. And that's where we need to provide the intervention, which one of the interventions is giving them more experiences on creating mathematics using dots. Picture is worth 1,000 words. Go ahead, Cheri.
One of the things that I want to emphasize to the occupational therapists that are listening to this is, please include the symbols, math symbols, in your therapy sessions. Explain why a parentheses goes to the right versus goes to the left. Explain it, and not just in literacy terms, but also explain it in its connection to mathematics. What are 3 ways that you can represent the divide sign? You have the dots on the top and the bottom. You have a fraction, which just has the line, and you have a horizontal equation. You can have it with the thing almost looks like a square root. That line, you've got the dots, you've got just a line. And what are some of those other ways that you can talk to your students about the representation of those symbols? and make connections for mathematics. I think I just, in my brain, created a new worksheet for myself. How many ways can you represent the divide sign? I remember, gosh, we were working together. Maybe this was back in 2019. I'm pretty sure it was before COVID. And you put up something that to this day, I still go, she went off on a crazy tangent and I still don't know that I fully understand it. And I represent it often because it made that much of an impact on me. And you asked me, how many ways can I write 8/12? And I looked at you and I went, "Oh, give me a calculator," because to me, I automatically know what the procedure is. I know how to get the answer on the calculator. Don't ask me how many ways to represent it. You did this thing called 20 ways, and one of the ways that you did it was with dots, and that was different ways to represent that particular number. And I just sat back and I went, I have a long way to go in understanding mathematics. And I thought that I understood mathematics until I sat with you for a day.
But that really sums up my story as well. I was that, I'm going to say, false positive kid in K-12. I achieved high. I was always told I was good at mathematics. I always had this perception that I was good at mathematics, got good grades in mathematics. So I decided to actually major in a mathematics area in college. I started in actuarial science, but as a sophomore in college, I failed my first math class, and it really made me question my own understanding. Just like Cheri said, she came to that realization at some point that, wow, do I really even know anything at all about mathematics? So I failed that math class, switched out of actuarial science. That's how much it affected me. Majored in just pure math in college, took me 5 years to get the 4-year degree, and then decided to go on and get my certification to teach. And I thought, oh, I can teach 8th grade mathematics because I at least know enough to teach 8th grade mathematics. What happened was, in the first 2 or 3 weeks of my first year of teaching, I thought I'm a brilliant teacher, and I would give my quizzes and my tests, and about half of my students were not able to do what I taught them. I was really questioning where that disconnect was, and the realization I came to was I really don't know math well enough to be able to give access to this mathematics. We did almost full inclusion. We still had some resource room for math where we had like pure tier 3, 100% pull out for mathematics, but we were trying to really get full inclusion, tier 1 core classroom. And we're recording this live today, and my intervention specialist who helped guide me through this realization of, do we really even know the mathematics to better support our students, is actually here live with us today. You know who you are. Thank you for being here. Would you like to say?
Good morning.
Hello. This is a fun story. Take us back, Christy. 1999. You saw this very young, early 20-year-old girl come in, and over the next 5 or 6 years, as we collaborated and worked together, you as intervention specialist, me as math classroom teacher, give me your perspective of this journey that we actually took together.
I feel like I was in the same boat as you as a student, where I always got great grades. I was not necessarily a straight A math student, but I could play the math student. I could do the math, just show me what to do, and I can follow the steps and I can get the right answer. I feel like when we first started teaching together, we were like, okay, if I can give these kids tricks and mnemonics to remember how to do long division and how to do subtraction and how to do different procedures, that it's okay, the kids have it. If I write those mnemonics out and I write the steps out, the kids can go home and they can do it for homework. Then in 2 weeks from now, I give them a problem again and they have no idea how to even start. I feel like what we learned together is that a lot of times we have kids that can play the math game and they can do the procedures, But in the end, they have absolutely no idea what they're doing and why. They didn't really understand the math. They didn't have the number sense. That's the biggest thing I felt was our journey working together, was how do we get kids to understand what they're doing and why, which is that whole importance of number sense, and how can we improve number sense in kids.
That's exactly the neurological philosophy. Neurodevelopmentally, gifted students will be able to figure things out and understand them in a few sessions. Typical kids, a couple more, but kids with disabilities and kids who are truly struggling. Initially, I had heard 60, but lately I've been hearing more like 300 times. You need to represent the number 2 300
How do
times.
we get more interactions with kids so that it increases their memory and retention? And that is through visuals. That's really what the phrase "a picture is worth 1,000 words" mean. And one thing I want to connect to what Christy said is, and I'm going to say this a different way, but it's what we learned in our journey, is that oftentimes we can get kids to replicate short term. Some of these kids, we can give quizzes and tests in our classroom, and they could score very high because it's in that short term. They're able to retain the information just long enough to produce on my quizzes and tests. But then we give a midterm or a final exam or the end of the year assessment or the state test at the end of the year, where they have all of these concepts all at once, where they have to pull from their memory and things that happened 5 or 6 months ago. That's where the breakdown is. We have some of these kids that achieve very high. They get A's and B's in math class, but then they fail or come close to failing that end of year test. And we're like, oh, they're just not a good test taker. No, that has nothing to do with it at all. Their brain has not learned in the way that increased the memory of this content, and they're not able to retain. A lot of teachers talk about this also when kids move through the grades. They get to 5th, 6th, 7th grade, and the teacher says, these kids don't know this. And the 3rd and 4th grade teachers are like, oh my gosh, we spent so much time on this. We did this with kids. The problem was they were able to get it short term, but without those visuals, we're losing that long-term memory and retention. So let's jump more into the mathematics.
If you want to hear a little bit more about that conversation, go to T1Interventions.com, sign up for the workshop, and you'll get the rest of the conversation.
What is impact?
Inclusion. And when I talk about inclusion, I'm talking full inclusion. How are we going to reduce pull-out sessions to 0? I know it might not be the perfect for all kids, but the full inclusion, if we're really looking at the definition, it requires professional development. It requires pull-in sessions for all disciplines. So inclusion is the first one. Metacognition, thinking about thinking. And that's all of these words and all of these phrases and these little nuances that Jonily teaches all the time. What do you see? What do you notice? Tell me about. Number 3 is perseverance. When we're toddlers, we're running around, we're curious, we're doing all these wonderful things. We're always trying to take the next challenge. How often does it take a toddler to learn how to walk? A few weeks. How long does it take an 83-year-old after they've had a stroke to learn how to walk again? Not a few weeks. It takes much longer. When we're looking at perseverance, we're looking at helping them create an innate sense of drive and motivation to accomplish something. When we're looking at A, we're looking at adaptability. Adaptability is more than just physically adapting the worksheet. Adaptability is also a change and a shift in your mind. When we're looking at C, we're looking at curiosity. I mentioned the toddler a little bit ago, looking around and doing all kinds of wonderful activities and being absolutely curious about their surroundings. We put them in kindergarten. Here, you need to sit in this seat. We confine them. We teach them this structure that we've created in the system so that we can get all kids learning at the same time. I would love to see, especially in middle school, kids on treadmills learning math. There's been a research study that talks about it where they were having this special ed class of kids who were failing math. They put treadmills in the classroom for this particular set of students. All 6 students aced their state testing that year because every time they came into math, they had the treadmill at a low rate of speed so they could still hear the teacher, and their math scores skyrocketed and they got the concepts.
Before you say the last one, I'm going to give the definition of this last one before we say the word. The T is a new path that doesn't yet exist, that Cheri and I are creating and hoping that it catches on. This isn't in addition to, it's instead of. It's the better way. It's the path unpaved that we have all the research to back it, and now we just need to take the step. So Cheri, give it to us. What's that last word that I've just defined?
Transcendence. It's a journey. It's not transformation, which happens instantly. It's transformation that happens from this point all the way to this point and beyond. It's that concept of lifelong learning. It's that concept of what we learn today, we integrate into our base of knowledge so that we can use it tomorrow.
All right, everybody, have a great weekend, great end of the school year, great summer. And we resume these tier 1s September 21st, the 3rd Saturday of every month.
And go into Disability Labs and register for September, October, and November. The dates are in.
That way you're registered in your login so that you get all the emails and the links and everything.
Everybody, happy summer.